Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on three-phase full-wave control rectifier and semi-converter. So first here, in the last lecture we discussed single-phase half-wave control rectifier with RL with freewheeling diode, RE and RLE load. And after that we have covered single phase full wave controlled rectifier and semi controlled rectifier. And also we have covered three phase half wave controlled and say uncontrolled rectifier we have covered. And next here today we are going to have a discussion on single phase full wave controlled rectifier and next three phase full wave control rectifier and three phase semi converter that we are going to discuss. So first, this is the diagram for single phase full wave control rectifier. Three thyristors T1, T3 and T5, T4, T6 and T2. So these are the odd notation, and next even notation. So this odd notation T1, T3, T5 is the upper group switches, upper group thyristors, and these are the T4, T6, T5. T1, T3 and T5 are upper group switches, and T4, T6 and T2 are lower group switches. Lower group switches. So now here to get the output voltage V0, so there must be one upper group switch and one lower group switch must conduct. So now here we are giving three-phase supply here, VA, VB, VC, phase voltage VA, VB, VC. So now here how you are giving the three-phase supply to this single-phase full-wave rectifier. So now here this is a VA phase voltage and this is a VB and this is a VC, VA, VB and VC. So now here the notation is here VA equals to Vm sin omega t. This is a maximum voltage Vm, and VB equals to Vm sin omega t minus 1 t. It starts at 0. So it starts at 0 and it starts at 120. So this is a 0 and it starts at 120. And next VC starts at minus 240. So this is the case for phase voltages. So now the angles. So three-phase supply we are giving to three-phase full wave controlled rectifier. So now here how thyristors will conduct. So now here these are the upper group switches, positive group switches, upper group switches, and these are the lower group switches. Compulsory there must be one upper group switch, positive group switch, and negative group switch, lower group switch will conduct. So now here at alpha equals to 0, what will happen? So now here at alpha equals 0, so now here T1 and this is 30. Alpha equals 0 means here T1 and T6 will conduct. So here T1 and T6 will conduct during this duration. Okay, na? So now here T1 means this one and T6 will conduct this one. So now here second one. So now here your output voltage here. This is the V0, output voltage V0. So now here to get the output voltage, here this one equals to VA minus VB, that equals to VAB, that is the line voltage. So now during this period, so the output voltage will follows the supply voltage. So now here if you see this one, so here this is the line voltage VAB. So VAB and VBA, VBC and VCA. So here we are getting the line voltage. What is the relation between line voltage and phase voltage? So now here this is the 0, 120 and 250, VA, VB, VC. So that I am drawing here VA, and next here VB, and next here VC, 120 and 120, and here 120. And now here these are the phase voltages. Phase voltages. Let me change the color over here. So this is the diagram. So now here this is the minus VB, and next here this is the minus VC, and this is the minus VA. So now let me change the color over here again. So now here this is the VA minus VB, that is VAB. So this is the 30 degrees. Total duration is 60 and 60, and here this is 30 and 30. This is VAB. And next here VCA. And next here vector summation of these two, here VBC. 30 degrees. So now here this is a vector diagram for phase voltages, and this is a line. These are the line voltages. So what is the difference between phase voltage? This is the phase voltage and this is the line voltage. So now here what is the relation between phase voltage and VL equals to √3 into V phase. So now these are the phase voltages and these are the line voltages. Now here VL equals to √3 into V phase. VM is maximum value, and here there is a difference. So 30 degrees duration, 30 plus 120 minus 120 minus 90. Minus 90 means this one is here 210 degrees. 210 degrees, not 120. Minus 90 plus 210 is 90 plus 120 is 210 degrees. So now here this is the case for this one. So now these are the line voltages. So now if you see the waveform, so this is the line voltage. So now here this is the VAB, VBC and VCA. So now here another one is this is 210, not 120. Now here VAB starts at 30 degrees duration. So 30 degrees duration means it starts at plus 30. So here 30 degrees, and here it starts at 90 degrees, and it starts at 210 degrees, 210 degrees. So this is the line voltage. So now here let me change the color over here. So first one is red color. So now how it will work? So from 30 to 90 degrees. 30 to 90 degrees. So 30 to 90 degrees. So which thyristors will conduct? So here one compulsory one upper group switch and lower switch group will conduct. T1 and T6 will conduct. So this is the T1 thyristor and this one is the T6 will thyristor. So middle one, and this is the first one. This is the output voltage. So now V0. V0 equals to VA minus VB. So that is VAB. So this is the line voltage. So now this line voltage means here. So here VAB means this is the VAB. It will follow the supply voltage. VAB you will get at alpha equals to 0. T1 and T2 will conduct, that is VAB. So from 0 to 90 degrees S. And after that 92, this is 92 and this is 150. This is 150. So now here 90 to 150. So which thyristors will conduct? T1 and T2 will conduct. So T1 and T2 thyristors will conduct. So T1 and T2 thyristors will conduct. So that is VA minus VAC. So now here VA minus VC, that equals to VAC. So now here VA minus VC means VAC means this is VCA. This is VCA waveform. So here it will follows this one. So this is VAC means here VCA means here, VAC means here this one, completely opposite to this one, VAC. So this is VCA. So now here you will get here, this is the VAC. So here T1 and T2 will conduct, here T1 and T6 will conduct. And next after that, from this 152 and next 210, next 152 210, T3 and T2 will conduct. So T3 and T2 will conduct. So now here T3 and T2 will conduct means here middle one. T3 and T2 will conduct means output voltage equals to VB minus VC, that equals to VBC. So that is VBC means here it will follow this voltage VBC. 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 And next case here from 210 to 270 degrees. So T3 and T4 will conduct. T3 and T4 will conduct. So T3 and T4 will conduct. So now here T3 and T4 will conduct means here. So this one will conduct. So VA, VB minus VA. So that is VBA. VBA means here this is the one. So now here VBA means here this is the VAB. So VBA means here VAB means that is this is VBA. This is VBA. So VAB, VAC, VBC and VBA. So this is the VBA. This is VBC. And next here from 270 to 330. 270 to 330, that is T5 and T4 will conduct. So T5 and T4 will conduct, that is VBC. T5 means here third one. And this one. So VC minus VA. So VCA. So that is VCA means this one. So same as it is VCA. And next last one here from 330 to 390. So which thyristors will conduct? So T5 and T6. T5 and T6 will conduct. So T5 and T6 will conduct means, so middle one. So that is VC minus VA. V naught equals to VC minus VA, that is VCA. So now VC minus VA, VC minus VB. VC minus VB means that is VBC. VBC minus. So this is VCB. VCB. So now here next again this cycle repeats. So from 0 to 90 T1 T6 will conduct, that is VAB, and 90 to 150 T1 and T2 will conduct, that is VAC, and next 90 to this 150 to 210 T3 and T2 will conduct, that is VBC, and next here T3 and T4 will conduct from 210 to 270. So that is VBA, that is this is VBA, and next here this T5 and T4 will conduct at 270 to 330, that is VCA, this one, and next here this is VCB. So between 330 to 390 T5 and T6 thyristors will conduct. So this is the output waveform for 0 to 30 degrees. So thyristors conduction time. So now here what about the 60 degrees duration? 60 degrees means alpha equals to 30. Alpha equals to 30. Same fashion how they will conduct. So this is the case for 30 degrees, 0 degrees, and here 30 degrees. So here it starts at 60 degrees. So 0 plus 30 means 60 to 120. T1 and T2 will conduct. 60 to 120 T1 and T6 will conduct means here VAB. T1 and T6 will conduct means that is VAB. V naught equals to VA minus VB, that is VAB. So VAB means that is this one. So now here it starts at here. VA minus VB. And next here T1, T2 will conduct from 120 to 180. So 120 T1 and T2. So this I will write, I will draw here. So T1 and T2 will conduct at T1 and T2 will conduct at, so this is the case for T1 and T2. So that is VA minus VC. So that is VAC. So now here VAC means this is the VCA. So VAC means here this is the one. So now here between these two, this one. So opposite to this one means here this one. So now here it starts at, so this is the case, and next again here. So this is the 60 and 120 and 180 degrees case. Here T1, T6 and T1 and T2. And next here 180 to 240, T3 and T2 will conduct. Here T3 and T2 will conduct means VB. So VB minus VC means VBC. So now here VBC means here this is VBC. VBC. So here T3 and T2. So VAB. So this is the VAC. Next here VBC. And next here between these two. Between this 240 to 300. 240 to 300. So T3 and T4 will conduct. So T3 and T4 will conduct means here VB minus VC, VB minus VA, VBA. VBA means this is a VAB. So now here this is a VAB means here this is the case. So now here it is opposite to this one. So now here this is the VBA. VBA. So that is T3 and T4 thyristors will conduct. And next here 300 to 360. Now here T5 and T6 will conduct. So this is the T5 and T6. So this is the case. T5 and T6 means here this VCA. So VC minus VA. So that is VCA. So V naught equals to VCA means here. So same as it is VCA. VCA, that is T5 and T4 thyristors will conduct. So this is the output voltage for at alpha equals to 30. Like this. This is the alpha equals to 30. So these are the thyristors conduction time duration and VAB, VAC, VBC, VBA and VAC. This is the case for 0 degrees case, and next here this is the case for 30 degrees case. This is the case for 30 degrees case, and next here for 60 degrees duration means alpha equals 60. So this is 0, and at 60 degrees they are conducting. So from 90 to here from 90 to 150 degrees duration, T1 and T6 thyristor will conduct. So at alpha equals from 90 to, so T1 and T6 will conduct. So T1 and T6 means here T6 is middle one and T1 is the first one. So that is VAB. So now here VAB means here this is the case. Like this. So now here at 60 degrees duration, so T1 and T6 will conduct. So 30 to it will follow the supply voltage. And next here, next case here again from 150 to 210. 150 to 210, T1 and T2 will conduct. So T1 and T2 will conduct means here 150 to 210. So 150 to 210, T1 and T2 will conduct. So T1 and T2 will conduct means this is VAC. VAC means here, So this is the case for between these two. So now here between T1 and T2 thyristors will conduct. So here T1 and T6 thyristors will conduct, and next here T1 and T6 will conduct. T2 will conduct. So now here what is the time duration? Here this is the one, and up to 150. So minus of this one, so that is VAC. Minus of this one, and that is VAC. And next case here, this one, this duration, 242, uh, 210 to 210 to 270 degrees duration. So now T3 and T2 will conduct. So T3 and T2 will conduct means here VBC. So that is VBC means here. So here VBC is here means this one. So minus of this one means it will come like this. So this is VBC. So VAB, VBC, VAC, and this is a VBC. T1, T6 will conduct, T1, T2 will conduct, and T3, T3 and T2 will conduct. So this is an 60, 180, 60 to 120, 150, 90 to 150. So that 90 to 150 that I am now writing. So 90 to 150, 150 to 210, 150 to 210, and 210 to 270. And next during this duration, so from 272 and 330, T3 and T4 will conduct. T3 and T4 will conduct means here T3 and T4 thyristors will conduct. So now here T3 and T4 will conduct means VB minus VA. So VB minus VA means here this is VAB. So this one, so it will come like this, and here this duration is opposite to this one means here, so like this. So this is the VBA, and next here this duration, and next here 330 to 390. So that is T5 and T6. So T5 and T6 means here, so VAC. VAC means here this is the VAC. So VAC means here opposite to this one. So now here VAC, this is VA, T5 and T4. So T5 is C and T4 is the VA. VCA. VA is not VAC. VCA. So as it is, so this one VCA. So now the duration from 90 to 150 and 150 to 210 and 210 to 330 and 330 to 390. So this is a 330 degrees. This is a 270 degrees, and here 390 degrees. So the duration, and here T3 and T4 will conduct, and here T4 and T5 thyristors will conduct. Next again cycle repeats, but here after 90 degrees. After 90 degrees here, so this is 0 plus, here it starts at 0, and 0 plus that 90 means here. So 0 plus 90 means here T1 from 120 to 180 degrees duration. From 120 to 180 degrees duration, T1 and T6 will conduct. So T1 and T6 thyristors will conduct. So that is VAB. So that is VAB means here. So that is here 120 to 180. So here 180 means up to here. 120 means here. So it is this one. So this is R load means it will not take opposite one. That is, it will conduct. This is a 90 and this is a 180. So it will conduct up to 150 duration only. So it should not be negative for R load. And next here from T1 and T2 will conduct 180 to 240. So 180 to 240 means here 180 to 240 T1 and T2 will conduct. So T1 and T2 will conduct means VAC. VAC means this is VCA, but here it is a this duration, this duration, but here it should not be negative, so it may come like this. So now here this is the from 180 to this is a 180, and next this is a 240. It will conduct up to this angle 210 degrees only. So up to 210, this is 240, this is 270, up to 240. And next here 240 to 300 T3 and T2 will conduct. So T3 and T2 will conduct means here T3 and T2 will conduct means here this is VBC. So this is a VAB, this is the VAC, and next here VBC will conduct. And next here VBC will conduct means it will conduct up to this 270 only. It will not be negative. So now here next case from 300 to 360 degrees duration. So T3 and T4 will conduct. So T3 and T4 will conduct means that is VBA. So that is VBA means here this is one. This one is the one means here this is the duration, but it will take only this one. So now here this is the VBA, and next here 360 to 420 duration T4 and T5 thyristor will conduct. So T4 and T5 thyristors will conduct means here. So that is VAC. VAC means here that is completely opposite to this one. So that is VCA. So VCA means here. So that is this duration VCA. And next degrees 420 to 180 T5 and T6 will conduct. So now here again T5 and T6 will conduct. So it will come like this. So this is the 90 degrees case, and this one is a 60 degrees case, and this one is a 30 degrees case, and this is the 90 degrees 0 degrees case. 0 degrees case, 30 degrees case, 60 degrees case, 90 degrees case. But here for RL load, so let me change the color over here. For RL load, inductor stores the energy in the form of magnetic field, and it will delivers the power to the load. So in the RL load it will be negative, it may be negative. This is for RL load. So this is for RL load. It will conduct up to 180, not 150. So this is the scenario. In the RL load, during this period power is delivered from load to the source. During this period power is delivered from source to the load, and during this period power is delivered from source to the load. These are the output waveforms for alpha equals 0, alpha equals 30, alpha equals 60, and alpha equals 90 for R load. And here the last case is the 90 degrees case only, it will be negative. So that is the 90 degrees case waveform. So RL load waveform may be like this. This reticular waveform is only for this one is for R load. Now let me write the average output waveform. Average output waveform equals, it is conducting up from 1 by 3, 30 to 30 plus alpha to 90 plus alpha. So now here this is 30 plus alpha to 90 plus alpha. So 30 plus alpha to 90 plus alpha. So that is the case 30 plus alpha to 90. These limits are important. 1 by 3. Each thyristor is conducting for 120 degrees case. Here 1 by third, 1 by 3, uh, pi by 3, 1 by pi by 3, 30 plus alpha to 30 plus alpha VAB. VAB means here that is root 3 Vm sin omega t plus 30 degrees. So plus 30. Sorry, this is VBA, I think. Now here that is root 3 Vm by pi cos alpha. And this is only for less than 30, but here greater than 30, it will conduct up to 90 degrees only. So now here that is VAB root 3 Vm sin omega t plus 31 by pi 30 plus alpha. So that is root 3 Vm by pi 1 plus 60 plus alpha. So this is the RMS output voltage waveform for 30 plus alpha to 91 by pi 90 plus alpha and Vm sin omega t whole square d omega t that equals to root 3 Vm under root 1 by 2 plus 3 root 3 by 4 pi cos 2 alpha. So these are the formulas. So now here, so first here, uh, circuit turn off time. Circuit turn off time. So Tc equals to omega Tc equals to alpha is less than 60 and alpha is greater than 60. So now here alpha is less than 60. Tc equals to 240 minus alpha by pi, and here in this case, so 180 minus alpha by pi. So Tc equals to. So now here another case, each thyristor is conducting up to each thyristor is conducting up to here what angle here. So here from for less than 60 here, uh, 120 degrees duration. So here IT average equals to 120 by 360 into I naught. So that is so I naught by 3, and IT RMS equals to IT RMS equals to IT RMS equals to IT average equals to I naught by 3, and IT RMS equals to I naught by root 3. That means here I naught into square root of 120 by 360, that equals to I naught by root 3. So now here, what is the phase angle source IS average equals to? So that is the case here. It is a symmetrical waveform that IS average equals to 0, but IS RMS value equals to, it is conducting for 120 degrees I naught into 240 by 360, that equals to I naught into root 2 by 3. So this is the case. So these are the important. And next here, three-phase semi-converter. So three-phase semi-converter means here replace these three thyristors, lower switch group, negative group switch with diodes D4, D6 and D2. The notation is same. T1, T3 and T5 are upper group switches. D4 and D6 and D2 are lower group switches. Same principle, only the difference here. So here the diodes conduction duration is from 90 to D2 is 90 to 210, and next to 210 to 330 and 330 to 450 duration, D2 and D4 and D6 duration. And now here first this is the notation for V phase line. These are the phase voltages and these are the line voltages VA, VB, VC and VAB, VBC, and this already we discussed. And next here what will happen? So first at 0 degrees case, at 0 degrees case, T1 will conduct. So T1 will conduct. So T1 thyristor will conduct. So T1 thyristor will conduct up to what angle? So now here T1 thyristor will conduct. So T1 thyristor will conduct. So T1 thyristor will conduct up to what angle? Here T1 thyristor will conduct for 120 degrees duration. So T1 and T1 thyristor, T1 will conduct up to here, T1 and T2 will conduct. So T1 and D6 will conduct. So T1 and D6 will conduct. So this is the T1 and here this is D6 will conduct at alpha equals to T1 and D6 will conduct from 0 to 90 degrees. So 0 to 90 degrees T1 and D6 will conduct means VAB. So that is VAB means here. So this duration VAB. And next here uh, T1 and D2 will conduct. Next duration, this is the duration. Here T1 and D2 will conduct. So that is here VAC. Here is also up to 120 degrees duration it will conduct. So T1 will conduct. So this is the D2. T1 and D2 means here VAC. VAC means here this is the case. So VAC means here up to 150. 150 means here. So it will conduct up to this one. So same as it is for 0 degrees case, same thing it will like this only. T1 D6 and next T1 and D2 will conduct, and next T3 and D2 will conduct like this, same as the single phase full wave rectifier with 0 degrees angle. So that is same, but here at alpha equals to 30 degrees, alpha equals 30 degrees, it will conduct up to 120, 30, 60, 90, and here 120 degrees, 60 to 180 degrees case. Here what will happen here? So T1 and D6 will conduct means it will conduct VAB. So T1 and D6 will conduct means that is VAB. So next here, this is T1. T1 and D2 will conduct from 92, here 92, and next here this is the case 90 to 180. 90 to 180 means this is the case up to this angle. So now here, so up to this angle means here, so here it will conduct from, so here, and next here up to 180 degrees case. So next case here, next case uh, uh, next T3 thyristor will conduct and D2 thyristor will conduct. So T3 and D2 means here VBC. VBC means here. So this is the VBC, and after that T3 and D2, and next here it will conduct up to 180 plus this one up to 300. So T3 and D4 will conduct. So T3 and D4 will conduct means T3, B and C. So B and C means B and A. So B and A means here this one. So that is completely. So here it will come like this. So I am drawing. So here it will, the diagram should be like this. And next here the diagram should be like this. Next again the diagram should be, so T1 D6 will conduct, T1 D2 will conduct like this only. T1 D6 will conduct and T1 D2 will conduct during this period, and next T3 and D2 will conduct. So T3 and D4 will conduct. Next T5 and D4 will conduct, T5 and D6 will conduct. Like this, these SCRs will conduct. Similarly, for 60 degrees duration, so SCR will conduct from, so 90 to 210. So 90 plus 120. 90 plus 120 means here 210. So it will, this is a T1. T1 and D2 will conduct. So T1 and D2 will conduct means here T1 and D2 will conduct. T1 and D2. T1 and D2 thyristor will conduct means here that is VAC. VAC means that is this is VAC means completely opposite to this one. This one. Completely opposite to this one. And next here here T6, T3 thyristor will conduct. So T3 and D4 thyristor will conduct up to here. So that is T3 and D4. T3 VB and here this is T3 and D4 VB and VC. So VB and VBA. So that is VBA means here this one. So completely opposite to this one. And next here uh, uh, T6, T5 and D4, D6 will conduct. T5 and D6 means here C and B. C and B means here, so this one. So now here, so like this. So this is the case for 60 degrees case. And again, 120 degree, 90 degrees. Alpha is 90 degrees case here. 90 degrees case means here the SCRs will conduct from 120 to. So these are the 90 degrees. So now let us, this is a 60 degrees case, 30 degrees case, 60 degrees case, and 90 degrees case means SCRs will conduct from 120 to 340. So during this period, so that I will explain. So now here, let me write. So this is a 90 to 240. So here T1 and here T2 and here T3. So T1 D2 will conduct. So T1 D2 will conduct. T1 and D2 will conduct means VAC. VAC means here. So that is this one. So here during this period, so VAC will conduct. So here this is VAC. So here completely opposite to this one. And next here T1 and D2 will conduct, D4 will conduct, T1 and D4 will conduct. So that is VA, T1 and D4 will conduct. So this is, there is no voltage, and here like this voltages will get. So 0 degrees case, 30 degrees case, 60 degrees case and 90 degrees case. So now here if you see the average output voltage equals to 1 by 2 pi by 3 integral of 30 plus alpha to 90 VAB, integral of 90 to 150 plus alpha, that is VAC. So VAB, and this is the VAC, and next final output is for less than 60, 3 root 3 Vm by 2 pi. And next this is the case for greater than 30 up to 210 degrees it will conduct. So 30 plus alpha Vm by 2 pi, that is VAC. So now here this is the VAC, and the final output is 3 root 3 Vm by 2 pi 1 plus cos alpha. So now here these are the references. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.